Okay, so this session is more of a Q&A, I think I said, but we're going to start with finishing the Cynefin conversation. I'm glad Thomas is here because he had started. He raised some good points, and I've been thinking about this a bit, and I think it hasn't changed my opinion, but it made it clear to me I wasn't explaining things well that resulted in questions. And it's interesting, actually, today. I wrote a post on this book I co-wrote. Like here, let me pull it up. I thought it raised some interesting things. So this came out a couple of weeks ago, a book that I co-wrote with Gary Rupp, Richard Nestor, Steve Pereira, and me. And it's mostly alphabetized. The reason Gary put his name first is because he's the one who led it, pioneered it, and did most of the work, or a lot of the work. I won't say most, but he did a lot more than me. That's for sure. And it was started out as him and me, and then we added Steve because Steve's got so much knowledge about value streams. And then we found that Richard was interested, and Richard used to work with SAI. I've known him for a long time, over a decade. And he's a very smart guy, very level-headed. Um, and we all collaborated on this. And so far, we've had 9 5-star reviews, 9 of 9. That's pretty good. And I was just kind of humbled by that. And I wrote something. I just started to write. Sometimes I do this. I just start to write something and I let what comes out come out. And I realized that there was a real lesson in this book, having nothing to do with the book in a sense. Yeah, it's good. There's no question the book is good. You don't get 9 5-star reviews out of 9 unless you've got something good. And the four of us, what's interesting, the four of us are leading edge in different places. I learned a lot from Steve about value streams. I mean, whoa. I don't mean the basic stuff. I knew that. His whole perspective on value streams. And I viewed them as different kinds of things. And he
Steve
viewed them as
also
a
authored
whole.
another book called Flow Engineering, I think. That's
Oh,
also
yeah.
very
Yeah.
good.
I've got that
Yeah.
book too. But yeah, we were doing this while he was writing that. So we hadn't read his book yet. But his whole mindset on value streams shifted my mindset on value streams. And I'm no newbie to value streams. I was using value streams back in literally the 80s. But anyway, then Richard is just he was so focused on that people would understand what we were saying. Duh. But it was so great because we were focused on explaining it, and he was saying, "Well, you're not really detailed enough here. People aren't going to get this." Oh my goodness, some of you have seen this already. So, and then of course Gary has this just wealth of knowledge at the organization level. So what hit me though was this question. How did four people co-write a book that's cutting edge and cohesive at the same time? See, that's an important question because there's a reason this happened. This wasn't one of those, oh, it just happened. We don't know why it happened. It was just art and the universe came together and light was around it. No, no, that's not what happened. There was a definite thing that happened. In the first, we recognized there were things you had to attend to. You can't just give lip service. I've been talking to somebody about they wanted to know if Safe can do hardware. And I said, well, I didn't think so, but then I decided to look it up. And yeah, they say, yeah, with Safe's with Safe's lean agile principles, you can figure out how to do hardware. Notice they don't tell you how, they just say with their first principles. Well, they're not their first principles, first of all. They're the ones they mention are Don Reinertson's, and they throw one of their own that Don would disagree with into that lump. So, and it's like, okay, 3 pages and you're done. No, no, I'm sorry. It's not like that. All four of us had a deep understanding of this and we aligned around this and we recognized our opinion didn't matter. I remember having this deep conversation with Steve on value streams where I had said something and he'd said something. And to be candid, I couldn't understand what he said. I mean, I was trying to fit it into my model and it didn't fit my model. And I couldn't figure out how he meant it on his own model. So we talked about it. Not like I'm right, you're wrong, I don't understand you, you don't understand me, nothing like that. Simply like, I get the sense there's some value here, but I don't understand it. So let's talk about it, not because you think it's a good idea, but because there's probably a good idea buried in all this. And we discovered that. And it was brilliant. And it shifted the whole value stream chapters we had. And then how do you explain something to people? So people realizing that how you explain it is just as important as what it is. So we had a pretty good book before Richard came on board. And then, man, he was such a pain in the butt, except we loved that he was. Oh my God, we thought we had this. And now Richard's telling us it's too vague here and they're just going to misinterpret it there. And, you know, so it was really interesting when you step and think about this, how four people, yeah, I mean, we knew each other before we formed. I knew Steve from a variety of things, I knew Richard, but we didn't like them because they thought like us. We liked them because of their integrity and the fact that they were coming from these three ideas. And these three ideas are lost in this community. Like, in general, like frameworks, like SAFe. And I'm actually going to write something on this because I've had two deep epiphanies about things I've done. And one regarding SAFe, like should they send somebody to an RTE course, release train engineer to do SAFe? But in fact, I stopped being an SPCT because SAFe as a framework by itself can't solve a lot of problems. And they said you got to do it by the book to keep your SPCT. So I left. So doing more of the constraints that frameworks put on you is an issue. And there's one other thing, and then I'm going to get into the Q&A. Sorry, I've just kind of this been top of my head just seeing that. I'm going to write a chapter. If you're interested in something like Scrum at Scale, wait for a chapter I'm going to write on it later today about the history of Blast. Blast was basically an Agile solution team. I had never codified it. I created it in 2008, I think it was, maybe 2007. I have a case study written on it. In fact, I'm not sure no, interesting case studies. Um, yeah, these guys here. I don't even know I don't call it blasts here. I just call this courting teams with backlog management. In fact, I didn't even think this was anything special. This is what's interesting, that I didn't think of it as anything special. Okay. It's case study two. I'll put where these case studies are. To be candid, I'm very disappointed in a sense that I talk about four miracles here in these case studies. And some people actually chastised me for saying I'm using theory constraints when I didn't. Well, it's just a piece of what I do. And mostly I never got, wow, that's really impressive. Is there a path we can take? And the path is this, is you follow the first principles. All of these were like, here's the summary of the savings. It's really just amazing when you think about it. 1.7 million on a $20,000 investment, whatever 25% of a 175 person development group is for less than 10. Now, I don't run miracles like this all the time. I wish I could say I did, but the fact that I could do it at all, the question is, what happened? And there's a parallel in that what happened, and it's going to be talked about in this thing. Yeah, I should actually add that this is about Blast, and I'll point to the book because we have a chapter on Blast. But here's what's interesting. The way I did Blast is I went to a company that had the development manager there was about to become a CST. So I knew they knew Scrum. Usually when people tell me they're doing Scrum, well, I don't believe them. And also Jeff Sutherland had been in there. So if Jeff Sutherland's been in a place and they got a guy who's almost about a CST, I was not so disenfranchised with Scrum back in 2008, but I believed them when they said two things. They were doing Scrum well, and um, they were also doing the equivalent of MBIs. We called them minimum business increments back in the day. And I had never come across a company that had been doing both at this time, but I believed them for a variety of reasons. I'm usually dubious about that. In fact, in one of my presentations, I have one plus one not equal to question mark, because why was I there? Doing Scrum well, using MBIs. Why am I there? And the reason I was here is they couldn't coordinate their teams. By the way, if you have to coordinate teams, what that is a symptom that you don't have alignment present. Good coordination is not a good thing. It's like saying, I got cancer and I got cured from it. Well, it's good you got cured, but it's not good that you got it in the first place. Okay. And I had abandoned Scrum of Scrums for years, which is what they've been trying to do. Even in 2008, we saw it didn't work in 2004. Anyway, we had a day's conversation and I couldn't understand everything. And then I used value stream analysis to see what was going on. And within an hour, I had them understanding what they needed to do. And this is the interesting thing. When they had the pieces, it took an hour to get the equivalent of Scrum at scale, only better, because my thing would work whether you're doing Kanban or Scrum. It didn't matter you had to have cadence. But this is an important distinction. This is why I'm starting to write more about Amplio and that it's actually does generate a framework but it isn't the framework. And Amplio itself isn't the framework. And I've been thinking about what the difference between a framework that's actually a framework you work from, such as physics. Physics does limit you in your thinking. There are laws of thermodynamics. If you start coming up with stuff that shows you're breaking the laws of thermodynamics, I'd be very dubious about it. People have been trying to break the laws of thermodynamics for years. It doesn't work that way. Okay. I mean, maybe somebody will come up with something in a few years that show you can break the laws of thermodynamics, but I'm doubtful when I see some explanation that does that, given people have been trying to break that one for hundreds of years. But here's the thing: there are no constraints in good systems other than you shouldn't be thinking about what you shouldn't be thinking about. So if you're trying to design an electric car that breaks the laws of thermodynamics and you're using a framework to tell you you can't do that, that's a good constraint. But if your constraint is having to take a particular approach, that's not a good constraint. That's limited thinking. Am I making it clear? And the reason this is hard is English language, all languages are ambiguous. If I say this tells you how to do it, I have not really told you anything. See how to do it. What does that mean? Does that mean just check every now and then, like Scrum sprints? Is that telling you how to do it? Well, some people say no, it isn't, because it doesn't tell you how to do sprints. But I think it is because it puts some constraint. So how is ambiguous? Is it giving you the specific details of it? No, but they still got how in it. That's a constraint. Anyway, I just want to mention this because what's interesting when I'm thinking about this whole thing with what do you do? Do you send somebody to an RTE class to be a release train engineer and safe, and then have them fit within the safe model? Or do you send somebody to, say, my class, it's not a class, but the Amplio University, where you learn to think in first principles? And this is my main point here. I think you have to learn well, it's a decision. You don't have to do whatever you want. But here's what I suggest is more powerful. You have the choice. One choice is you can join a framework, learn a framework, and learn how to work within the framework. And I don't care if they say it's a wrapper and you can do whatever you want to because it's immutable. We're slide tracking off the Scrum here. Or you can learn what works and use the framework you're working in as a collection of what you're doing with what works. There's a lot of good stuff in Scrum, a lot of good stuff in Safe. But the question then becomes, do you follow and then are limited by those frameworks, or do you learn how to think within the frameworks and go beyond them, recognizing when their constraints are not something you want to follow? But here's what I think is most interesting. Scrum at Scale is a 2-day workshop. And Scrum at Scale took several days to work. And I know, I'm not saying Jeff took what I did in Blast. I have no idea what he did. But I do know that where I put Blast in the first place was at a client of his, so he knew about it. But the point was this: I built Blast in an hour. once they understood principles. Whereas with Scrum at Scale, you got to study for 2 days. Now that's actually what's interesting to me. And the reason I didn't do anything with Scrum at Scale is I just thought of it for, I hate to say it, but like for uh, 10 years at least, maybe longer. I just thought of it, oh, it's just one off of applying principles. I didn't even really think much about it. I didn't call it blast. It was when a friend of mine talked to me about Scrum at Scale, and I looked at Scrum at Scale and I said, this is just like blast constrained to Scrum. And then I realized there's huge power when you can combine first principles to your needs. And it's actually, and it doesn't take long. Everybody thinks it takes long. It takes less time. Literally takes less time to do that because you're not limited in your thinking. Anyway, gonna stop there. Any questions about what I said, I'll deal with. I'll be happy to talk to you. Otherwise, we're going to shift into the topic. Sorry for, thank you for indulging me. I won't apologize for it, but thank you for the indulgence. Any questions about what I said? Okay. So what I want to do is Thomas started, I think it was 2 weeks ago, this thing about Cynefin. Okay. And he raised some very good points. And I realized my thinking was unclear about how I was presenting my case. Okay. So, Thomas, what I want to do is restate my case in 5 minutes with the clarity I think you're the judge, not me. I think will address the issues you brought up. Okay. And then if they don't, let's keep talking about it. And if they do, then it'll be a shorter conversation. Okay. So I'm not trying to convince you of anything. I'm trying to be clear about what I said. Now, one of the things he had said was how Cynefin is very useful, and it actually is, to convey to people that we're in a complex situation and things just don't happen the way we want them to happen, and that it's not all simple or we can figure everything out. Um, was there anything else that you remember? That's the main point I thought, and that's what I've got this 5 minute addressed. But if there was something else, I want to make sure I can cover it in my 5 minutes.
Yeah, well, first off, I don't think I started the Cynefin comparison, but I think
Oh,
I took um, I disagree perhaps with some of the statements that were made around it. And one
yeah,
thing that I do remember, not very clearly, but I can look at my notes as well,
that's
is what was with the root causes of some of complexity, or with complexity and nonlinearity,
ah,
and some of those things struck me as perhaps not doing justice to the chaos theory and so forth. For example, I remember you had said something to the effect that complexity is not our problem, but nonlinearity is.
yeah,
And
great, great, great. Thank you for reminding me. Yes, I
I
can
see it
cover
more
that.
such that nonlinearity is what causes complexity in the first place. In fact, there
Yeah,
is no complex system that is linear. It has to be nonlinear. So it's a necessary, but maybe not necessarily a sufficient condition for complexity. So and how we deal with the complexity that these nonlinear systems can create. That's the question.
yeah, yeah,
And
very
how
good.
useful the Cynefin way of looking at things is that is maybe up to debate.
Okay, no, that's good. Thank you for this because I remember that part now. Yeah, I actually I'm going to suggest that you have nonlinearity as the cause of complexity, and it isn't. It's the other way around. And by the way, you can have simple systems have be nonlinear. There are simple systems that are nonlinear. In fact, the straw that broke the camel's
Right.
back is a
Yeah.
simple system that's not linear.
Nonlinearity doesn't imply complexity, but you cannot have linear systems exhibit complexity. So nonlinearity
Actually,
is a required ingredient for complexity.
yeah. Uh, Yeah, but nonlinearity is an effect, not a cause necessarily. So yes, nonlinearity is typically present in complex systems, but the question is it a cause of the complexity,
Yes.
or
In my
is it?
opinion, yes.
There are two causes for complexity. By the way, Cynefin does not talk about chaotic chaotic systems. He refers to chaos as a state. That's another funny thing. I've always thought that was really weird about Cynefin is Chaos is one of the four states or five states because you got Discord or something in the middle. He changes the name, so I'm probably getting the names wrong. But that's not my point anyway. So there are two main points here, and thank you for bringing the one up on on nonlinearity. I'll give you an example of where you can have uh, you can have the a complex system where you don't have nonlinearity is when you can't quite understand what's going on, but you can kind of nudge it in the right direction all the time because it's at least somewhat behaving you. Nonlinearity, when you have nonlinearity, and just to be clear, we know what we mean by nonlinearity is is when a small event causes a big problem. Now, the Piper alpha is a good example of complexity causing nonlinearity. The Piper alpha was a
Oil rig.
oil rig, yeah,
Yeah.
in the North Atlantic that blew up. And it definitely had nonlinearity characteristics to it. Uh, but the cause of the events that then blew it up had nothing to do with nonlinearity itself. The cause, when you really get down to it, what happened is they had taken one of the pumps out for maintenance. By the way, there's a great National Geographic on this, or Seconds from Disaster. Look for Seconds from Disaster, the Piper Alpha on YouTube. It's free. It's about a 45-minute video. It's really wonderful. And basically, what happened is they had two pumps. They always have a backup pump on this kind of thing. And they had two pumps. And one pump they had taken out for maintenance, out of service for maintenance. That's not a big deal because you can just, you can do what you need to get it running again. But it wasn't the big deal. And that wasn't the cause of what happened. What happened was that they had some other event. So they had these two pumps, and one of the pumps starts going badly. So they said, oh, well, let's just turn on the other pump. What they didn't know is the other pump was out of service. And the reason they didn't know the other pump was out of service was because the way they did things was they had some little, maybe I'm making your point here too, Thomas, now that I think about it, but that's okay. I'm not trying to win. I'm trying to understand. Okay. So one of the things that happened was that they had filed the paperwork for maintenance, and they'd filed the paperwork for the completion of where it is in different places because they filed it according to who was doing the work. It made sense from a filing point of view. It made no sense from an operations point of view. By the way, this is a good insight. How you look at the system. Do you look at it from how things work is done, or do you think work on how things were documented? They were thinking about it how it was documented. So this, in a sense, was complex and chaotic. What happened is that triggered the events because they turned that pump on, and that pump would not been sealed properly. They put the cover on it, but they hadn't sealed it properly. So when they started putting natural gas through it, it leaked, and then that caused an explosion. So there, actually, I'm making your point, Thomas, because you had a non-chaotic, you had this there and that there. See, to me, that was complexity, but then it caused that non-linear event because they didn't know that. So it was not knowing this caused the not something. Now I'm back to making my point. But you're going to have to tell me if I am. So I'm going to restate it, making my point, and then you can tell me if I've convinced you or not. But then there's a lot more about Piper Alpha that's really fascinating. So So what happened is because they didn't see what was going on, they had this lack of visibility. They didn't know that the pump turning it on would be a disaster. That triggered an event. Now that wasn't in and of itself though the problem. That caused a minor explosion in the on the Piper Alpha. Not good, but not a disaster yet. But what started happening then was then the liquefied natural gas started leaking or going to another area, and they had designed the system to be so that if anything like this happened, they had these metal grates outside, which were the stairs, and the water, not the water, anything oil or something like that would go and fall down into the ocean. However, you had the skin divers or scuba people who do maintenance on the rig. if you've ever stood on a bare metal grate with bare feet, it's painful. It doesn't cut, and it's very uncomfortable. So what they used to do is they used to put a plastic tarp, not a thick rubber tarp, better word, on top of the grid because it would make it so they could stand on that. Now, the problem was then when the oil came across, it didn't go down, it stayed there. Now, here's another problem. So it caught fire there. That in and of itself wasn't the problem. However, there was a pipeline about 3 feet, 6 feet, something like that, above it. It was about 6 feet. It was clear of the head, maybe even 8 feet. So when you got the fire here, and the pipe above it, that was basically a pipeline that went to another platform where they moved the natural gas off of this platform, the other platform. Now you had a fire underneath that, and the pipeline was above it, and guess what? That exploded, and that's when the rig went up. Now, this is a complex situation. There's no way that they had visibility on what the maintenance crews were doing with their paperwork to see what was going on. That the scuba divers would put a rubber mat on the place that was supposed to vent the oil, and that you had a pipe above it. And then, yes, there was a series of nonlinear events, but each one happened because nobody had figured out the consequences of how everything was put together. Okay, so let's just talk about this point first, and then I'm still gonna. There were other things that were present, but this is good, which is cause and
Yeah.
effect.
Yeah, and I mean seems to be a characteristic of many disasters that
It's all of them.
they are the result of a chain of events, each one of which is often, when you think about it in isolation, you're like, yeah, it's not such a big deal. It's bad, but it's not a disaster. But the chaining of all those things, there's obviously the combinatorial explosion of so many, 2 to the power of n different ways how you can connect n different binary events. And nobody can sort of foresee all these combinations. And in many of the disasters, in hindsight, it was like, yeah, one could have thought about that, but the hindsight bias, right? So
Yeah,
we
yeah,
just don't
yeah,
know.
yeah.
And now
But see,
back,
I'm
go
sorry.
ahead.
No, 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 I didn't mean to cut you off. Sorry.
Yeah, so that aspect I totally get, and that's what we commonly describe as complexity, right? That there's so many different ways the system could interact that we can't think through all of them ahead of time, and in a way we can just react to what's unfolding.
Right.
But
That's
back,
really well said. Now let's just take one. Let's take a case
Mhm.
here. What if, what if there was a way to shut that pipeline that was above the stairwell? What if there had been a way? What if we could have seen what was going on and we could have shut that off? Now, there's no way we could have seen it because nobody was monitoring it, and there's no way to shut it off because it's a physical thing and they didn't have that device in.
I think that gets at a very interesting question, namely, if you had perfect information, could you have avoided it? And
Yeah,
I doubt that that's the case because of what Stephen Wolfram refers to as the computational irreducibility.
yeah, no, I'm being hypothetical here. I'm
Yeah.
not saying you could do this.
Or
You can't do this in the
remember with
physical.
9/11, right? When they started analyzing,
Yeah,
there
yeah,
was
yeah. No,
visibility in the fact that people took training and they didn't care about landing planes. They just cared about flying planes, etc. So in hindsight, one could say, oh, there was a clear tell that they were up to no good. But even if you have this information ahead of time, there's just too many different ways this could all unfold. And so I doubt that the visibility alone or lack of visibility is the reason for these
yeah, no.
blowups.
This is great, Thomas. I love talking with you because you just brought up another issue. It's not whether it's visible, it's whether you look at it. They told the FBI they were going to crash planes into the towers. They told them they were going to do that.
Yeah.
So you're right. So there are two things here. So I love this. This is really a great conversation. See, this is why I love having Thomas in my class because when you get into things like this, he's in the ACE program. When you get into stuff like this, you get to learn it so much deeper. So this is perfect conversation. So let's make two or three things here, and I still want that 5 minutes at the end. But this is a great conversation. So the thing is, I wasn't actually suggesting it would have been possible because nobody would have thought you'd ever need it. But what if it was possible? And what if you could see it? Two what ifs that I don't believe. You could have shut it off and the disaster would have been wouldn't have happened.
Averted. Yeah.
So I'm pointing out two things here because I'm going to tie it into knowledge work. And then I'm going to come back to your point because it's brilliant. It's just brilliant point. The the first point is in hardware, you can't see everything. And even when you could, you couldn't do much about it anyway. You know, like when there was another seconds disaster about the Concorde crash. And like once that plane was on fire, it really didn't matter what happened. I mean, or actually it was even before then. Once it started sparking and the fuel line had been cut, it was over. They couldn't do anything about it. So in the physical world, even if you saw it, you typically can't do anything about it. And what you're bringing up though is even when you can see it, and this is something people don't talk a lot about in the agile space. People don't look at what they see. What they see is what they think and talk about. Everything gets filtered through their mindset. When somebody tells them, that's a great example, when somebody tells them we're going to fly planes into the Twin Towers, the FBI agents are thinking, oh, these people aren't smart enough. They were discounting their ability to do something like that. It was so absurd that these people would do this. There's a certain degree of racism in this, by the way. And I'm not condoning terrorism, but or what they did, but it's definitely clear that there was not given much credibility. In fact, if you study warfare, you find that the biggest disasters are when the generals know the other people can't do anything. World War One, I mean World War Two, the Blitzkrieg is an example. The Maginot Line was impregnable, and you can't get through the Ardennes Forest. It was really clear you could get through the Ardennes Forest, but that had been said so many times. We don't think and talk about what we see. We see what we think and talk about. Oh, it's impregnable. You can't get through the Ardennes. So that's what people see. So they did not see this. So you're right, Thomas. Visibility without actually seeing it, information without actually seeing the meaning of the information is useless. I totally accept that point, and I think that's a brilliant observation. So now we have three questions when we go to the knowledge work, but I'm still going to do that 5 minutes, and then we can throw this in. The three questions are this: is can we see it? Can we see it like we're going to do something about it? And can we then do something about it? Does that make sense?
Yeah, I see at least the two different things, right? Is it
Please.
visible? And then do we react to it in some
Okay,
way?
is it visible and do we react to it? And
Yes.
can we react to it? I mean, in other words, in a lot of hardware situations, look at 3 Mile
Yeah.
Island. 3 Mile Island, what
Fair enough.
happened basically, well, actually, they could have reacted to that. They didn't know what was going on. So 3 Mile Island is not a good example. No, okay, Chernobyl, better example. See, in 3 Mile Island, you had a valve get stuck, and then a misreading of where the water was. It's amazing how it's just amazing how the China syndrome pegged almost exactly uh, the some of the misunderstanding that happened before 3 Mile Island. That's what's amazing. It didn't happen after. But anyway, at Chernobyl, there was a point that they couldn't see what was going to happen, but once a certain chain of events happened, there was nothing they could do about it.
Yeah.
It was just a poor design, the way the fuel rods work. By the way, if you wonder, boy, Al must read a lot about disasters, and the answer is yeah, it's kind of a hobby of mine. I do it for two reasons. Well, maybe three reasons. One reason I do it, I find it interesting. I'm not really that morbid. I just find it interesting because part
Mm.
of me is an engineer. The other reason is it's worth knowing, and I remind myself of this. See, people look at the Titanic and they think, oh, how stupid. How could they think this? How could they think that? But you got to remember, the Titanic was like the best of the best. It was the White Star Lines. We are amazing. They spared no expense on this ship. They had the best designers, the best, well, they thought they were the best builders. It turned out that was a mistake. But it wasn't they got this, oh, we can get this guy on the cheap to design the ship for us. No, this was the best designers. When best designers make mistakes like this, that means you might make mistakes like this. I might make mistakes like this. I read disasters because
Yeah.
it's kind of humbling.
Nobody's immune to
Nobody's immune. In
systemic
fact, the more
disasters.
you know, the less immune you are. I mean, most disasters that happened, there were warnings for the disaster before they happened that were ignored by the people who kind of knew what was going on. Because, Tacoma Narrows Bridge, the guys, people actually told them. I didn't realize this, but I studied it. People told them wind would be a problem. He said, no, it's not going to be a problem. I've built bridges. It's not a problem.
So back to the three things that you'd said, I see
Okay,
that
so
now. So
there's,
one is, can we see the problem?
do we
Two
react and
is, do
can we
we
react?
do we choose to react to it? And then three is, even if we wanted to react, is there anything we can do about it
Yes,
at that point? Yeah.
totally
Okay.
agree.
Yeah.
Totally agree. Okay. So I totally agree with that. But I'm going to now restate it that complexity makes it so we can't see all the things that are going on. And it causes this cascading sequence of things that therefore ends up happening as we end up with a nonlinear event because we cannot see this cascading effect before the fact. And even if we could see it before the fact in hardware, we might not pay attention to it. And even if we do and choose to react, we may not be able to. Is that a fair statement?
Yeah.
Okay, good. Yeah, and I really like this because this is going to challenge me now in the Amplio system. I have a way of creating visibility, and now what I have to make sure of is that people will choose to react to it. Because to be candid, I mean, I'll admit, I was thinking if the data is there, of course you're going to react to it. But you're right, they may not. So that's a gift. So I appreciate that. Okay, so let me tell you the 5 minutes. So I've been thinking about this, and that was a good thing. And I highly recommend reading these because you or watching a couple of them. There are about 10 or 20 of them. They're all fascinating. Um, there are all sorts of interesting things. Like they even have one on 9/11, why the towers collapse. What happened there? Why did a well-designed, it was a well-designed structure. Uh, and it wasn't just well, anyway, I don't need to keep giving examples, but it was well designed, but there were a combination of factors you could not possibly foresee, like the plane's impact would knock the asbestos insulation off the guardrails, and then that caused them to melt. I mean, who would? Well, you'd have to have a plane hit the building for that to happen, and that ain't going to happen. So anyway, it's just over and over and over again. So I appreciate it. So anyway, here's the thing. So let's talk about how to look at complexity in knowledge work. Okay. By the way, there's a fascinating book called Normal Accidents. Um, and I think this is where this chart comes from. Um, Here, actually, I'm pretty sure I have this chart. I actually talk about this in, no, what am I doing? Books. No, let's do it so you can see how to do it. Sorry. Okay, so if you go to my website, you go to resources, you go to books. I've got about an 80% finished Amplio development book. So I took the go to the book, and there's an online copy of this. I've got to rearrange some things still. It's not complete, but I'm going to start working on this, get it done. And in here, okay, there's this fabulous book. Again, this is really interesting. I read this book ironically because Snowden and I are disagreeing with things. And I made some comment in the reference research I did, I came across this book called Normal Accidents. And what happened in this was he studied the 3 Mile Island. He was asked to study the 3 Mile Island. And what happened is he noticed some patterns in the 3 Mile Island. And he decided to then write this book on the basis of that. And it's really a absolute brilliant book. But he breaks this a different way, that they're complex systems. You have either linearity or complexity, and then you have loose coupling or tight coupling. Like in the Piper Alpha example, there wasn't loose coupling. All these events were tight, but you couldn't see them. Notice where a power plane is. It's complex, and you have tight coupling. That's the problem. That's where you get the cascading event, and you don't see the coupling typically. Okay. Notice where R&D is. where universities are. It's complex, but it's not tightly coupled. See, I would suggest knowledge work is down here because we can do things with it. But if, and again, this is just an interesting book. If you like, oh, I didn't mean to do that, but if you like books, this is great. Now, it turns out he's wrong. This is kind of the interesting thing. He says he calls them normal accidents. He predicts that we would see a whole bunch of these because you cannot control complex situations. And somehow they have to date. There haven't been really a lot of problems with nuclear reactors like he had predicted. But it's still a fascinating book. Anyway, okay, let me get to my 5 minutes. So we had a video on this. This actually is on, again, our website. Go to the, I'm sorry, I'm jumping around, but those of you who know me know that's just the way it is with me. Okay, so you can go to resources, you can go to YouTube playlists, and on the foundations, I put them all here under foundations. First principles of knowledge work in dealing with complexity. By the way, since I'm here and I did this, I sent you all a note, but I just want you to see it's there. If you go to the website and you go to Amplio University and the Amplio Community of Practice, I have set up what I call a curriculum page for this to try to coordinate all this stuff because I know I throw a lot of stuff at you, and here's how you can find it all. Amplio Foundation, books of interest, the different case studies, and an elucid board, okay? So just go to Amplio University, Community of Practice, right here. Okay, so I'm kind of coordinating that. But anyway, coming back to this. So the question is, how should we think about it? I actually suggest there are three questions here. First of all, we have to recognize that complexity exists. That was the thing that struck to me, but I appreciated this other conversation more. How do we recognize complexity exists? Because a lot of people think that management thinks it's not complex and you can just dictate it. And I don't think they think it's complex. I've never actually met a manager who thought we can just dictate things. They think that dictating things is the best way to do it, which is different than thinking it'll actually work. I've had conversations like this for 40 years. Oh, yeah, I know that there's uncertainty. I know this, I know that. But if I put the pressure on, if I tighten the screws, if I get the whip out, they will work harder. Well, I remember having a long conversation with a client of mine. I wasn't there to help him with that thought, but I remember having some long conversations with him. Totally disagree with him, couldn't convince him otherwise. That was the 80s. I wasn't a good trainer or coach back then anyway. I was decent consultant in situations in there. So the thing is, we got to recognize that there is complexity. And I find the easiest way to do that is not by professing a solution, but just talking about it. And this is where I like VUCA: volatility, uncertainty, complexity, and ambiguity. When you talk about it that way, management knows, oh, yeah, we got things change. Oh, yeah, they're uncertain. Oh, yeah, they're complex. I can't see everything that's going on. That's why I'm going to push them to work harder. And yeah, it's got ambiguity. VUCA has been around for a very long time, and it's very well written up. And I've never found anybody who disagreed with it. The question is not, does complexity exist? The question is, what do you do about it? How do you look at it? So that's the first question, is recognizing it. VUCA is my choice. The second way is, how do we think about complexity? Now, I agree with you, Thomas. You can't see it before the fact. That's the nature of complexity. Okay, but that's not quite what I mean by how do we think about it. Then the question is, what do we do about it? So here's the thing. Here's the thing I need to establish first is, and everybody knows I'm talking to y'all. I'm not just talking to Thomas. One of us, I think Thomas already knows. So first principles give us the clue. What first principles do for us is they give us theory. And I mean, I got dozens of quotes. Einstein, Da Vinci, all these people talk about, if you don't have theory, you're lost, basically. Okay. Empiricism is insufficient. I love this one because this is used actually to contrast between inspect and adapt, which is just experience and adjusting to doing better, versus plan, do, study, act, or uh, check, act. This is another key point. This is the story of Semmelweis. I'm not going to go, but he's the best example I've seen. But if you study history, when people don't understand the theory underneath something, the explanation as to why it happens, they do all sorts of crazy, they either do crazy things like cargo cult, which was when, they discovered in the Polynesian islands these what looked like airplanes made out of sticks because these people had seen airplanes up in the sky and these great crates of food and all sorts of things came out of the sky. So they put cause and effect. What they were misdropped army supplies. And so you either get cargo cult because you hope something's true or you actually disavow what is happening. And a comfort zone has less to do with control and more to do with knowledge or the lack of it, according to Goldratt. And I agree with this. Management holds on to the past, not for control, because they're afraid to go with something they don't understand. Okay, now I'm not going to go through all this, but this is the key point here. Inherent simplicity in a nutshell is at the foundation of all modern science. As put by Newton, nature is exceedingly simple and harmonious with itself. Okay, I know Einstein disproved some of Newton's things, but believe me, in our world, I've never gone down a subatomic particle or gone near the speed of light, although a policeman once thought I was getting closer to it than I should. But I mean, within our natural world as we react to people, Newton was right. Yes, and I know at the subatomic level and nuclear and fission and all that, Einstein was right. But in our domain, I'll go with Newton. Okay. My wife asked me if she was gaining weight. I said, well, if you slow down a little bit, you won't have so much weight because, your mass increases as you go. No, I'm kidding. The jokes can just come forever if you think about this. Anyway, sorry, that's a new one. Uh, okay, this is the key. This is the key. If we dive deep enough, we'll find that there are very few elements at the base, the root cause, which through root cause and effect, governing the whole system. Now, when I read this in 2019, now how do I know I read this in 2019? Because my IP was purchased by the PMI in 2019. And I had been struggling that was 2019, around 2005 to 2019. What I had noticed was that there were a few things that made a difference, and I couldn't figure out what to call them or even what they were per se. I had a sense. And I read this and I realized I got it. It's these first principles. It's this thing like delays cause waste, multitasking causes inefficiency, etc. And this gave me that clarity. So now I'm going to get to what I wanted to talk about. So first of all, this is another good distinction. This I got from Don Reinertson. There's micro predictability. Is it going to go red, black, or green? I don't know. Who knows? But I know more money staying at the table, especially when I gamble at a roulette table. I did win once, but I was lucky. So here's the point. How do you deal with complexity? How do you look at complexity, rather? And I'm not sure I have the picture I want here. Oh, I do have the picture I want here. Oh, yeah, here it is. Navigating complexity with fast feedback. So there are two ways to deal with complexity that are kind of common, or maybe there are more than two. My way is this. I don't need to talk about what Cynefin does. I'm going to talk about my way of doing it. So there we go. Hey, easy to block out. Okay. So remember, I'm a systems thinker. I believe in systems thinking. I believe, I'm not saying it's complete, I'm not saying it's everything, but systems thinking basically tells us three or four things. One, we want to look at the relationships between things, not the pieces themselves. It's the relationships. We talked about this. You could put the best pieces from the best cars together, but they don't relate. You got a pile of junk. Also, that systems inform behavior. And there are two insights here. One I just got recently. That's I've been doing it, but explicit statements are important. One I've been saying for years is that if something goes wrong, you want to look at the system first before you go blaming somebody. And then as a team with management, you improve the system. Okay. But that case study that I did, uh, where I talk about the salon business, again, under resources, you can go to case study on for creating better products. Again, I have that on the curriculum map too. One of the things I did here was the best way to change behavior is to change the system people work in. Now, normally we talk about that to improve the failures of the system, but in this case, I use the system to enable people to do something they wanted to do but was unable to do, which was to give better recommendations. So systems thinking actually works both ways. It not just about the relationship, it's not just about when things go wrong, it's also about a way to encourage good behavior. Okay? Like making systems safe is a way to encourage good behavior. So here's how I look at it. I look at it, yes, we cannot see ahead of time. There's too much going on. And there's some relationships we can't see at all because they're too complex. Okay. Or too complicated or whatever. Okay. But we can see some relationships. We can see that if you yell and scream at people, or if you fire people, or if you take away their rights, they will not behave well. That's a simple relationship. You can see that all the time. There are also complicated relationships, which is if you have people spread across multiple teams, you will get effects you don't know, and you're going to cause waste. You're going to cause multitasking. There are a lot of factors there. It's complicated. There are some nonlinear relationships you can also see. Like if somebody's missing, I know it's going to cause an impact on something. So I might try to make it so certain meetings have all the parties involved because I know if this person's not there, we're going to miss something. And oh my God, it's going to be bad. And then we know they exist, but we can't see them by definition of what complexity is. We know there's relationships out there we do not see. There's no question of that. I've never denied that. We're in a complex relation system. In fact, I've said that all knowledge work is complex. This thing that things work in complex systems is irritating to me. Well, that says things work when people are breathing. Absolutely agree with that, but it's not very discerning. All knowledge work is complex. Why? Because you cannot get inside somebody's head and people are weird. People do things. Actually, they're not really weird. They're weird to you. To them, it makes total sense what they're doing. Okay. We are imprinted as kids in doing things that make no sense, but make sense to us. We have trauma and or perceived trauma. I was a very lucky kid. I had no real trauma that I'm conscious of. I did almost die as a child, but I have no memory of that. I had a disease. I was an Rh negative kid. It was things that happened. But anyway, but that's not where my trauma came from. My trauma came from perceived mistreatment by my mom of abandoning me. She didn't abandon me, but boy, I had that impression because she had to take care of my sick brother. We all have had stuff like this. And then some people have had serious trauma. I mean, I'm not trying to dismiss that either. I mean, people are starved or beaten or their parents were killed. You know, racism in this country has been wild. And a lot of people have had trauma. I didn't have trauma, but I made it up. We all make it up. So that's why we're in a complex situation because there's no way we can tell how people are going to react. So if people are involved, it's complex. So what do you do? Well, I'm suggesting you can't do anything here, as you well said, Thomas. You can say you can do something, but nobody's that smart. Nobody's precognizant. I'm not. You know, I love Mark Twain's comment prediction is difficult, especially when it's about the future. So we can't do anything here, but we can do stuff here. And this is my way of dealing with complexity is you make everything visible and you make it so you have reversible decisions. See, remember that nonlinearity, that Piper alpha, those were the two things. We couldn't see it. We couldn't do anything about it if we did see it. I believe we can see it and we can do something about it if we set it up that way. And you've added this, oh, I can't just make it visible. I have to make it clear why you better do something about it so people listen to it. Okay, I think I've given that's my more than five, but that's I'm done with that. So you can are we in agreement or what edge do you have on this? Because your thinking is really good.
Yeah, um, you used to talk about decoupling things. Can you explain on that? I know you used to talk about decoupling as to help navigate complexity.
Yeah, let me mention that and then I'll let Thomas finish it. But it's a great question, Abizi. So one
Okay.
way you decouple is you want to decouple the actions of teams from each other, and that's where looking and doing value stream analysis to have more or as close as you can get to having cross-functional teams is a good idea. Because if you don't have cross-functional teams, then you've got a variety of dependencies, and somebody might not be available when they need to be available, so you trigger a nonlinear event because something wasn't known, or you inject delays. So decoupling of the events you're taking place is important. Uh, so that's good too. So part of it is not just visibility, is not just that you can act on it, but that you try to decouple as much as you can. And that's where a lot of agile practices are quite good. So thanks. That's something else we need to put into the mix. Thomas, I see you're off mute.
Yeah, so I certainly agree with your rendition this time and the prescription, if you will, to focus on the simple and complicated areas, to make things as visible as possible, to encourage fast feedback, and to make things reversible. That is to say, that if you realize that you're going down the wrong path, that you can back up and sort of undo that. And in some of the disasters, there comes a point where one crossed the threshold where that reversibility was no longer given.
That's
Well,
right.
right?
In
Once
the
the whole oil rig is on fire, you can't just say, "Hey, let's back up a moment here and let's close this valve and try again." There comes this point where it's tipped over and then everything is lost. And I think there's also a nice connection there to the design patterns movement, which is, how I got introduced to your whole world of thinking some 30 some years ago, where this to the reversibility or to prevent these cascades that ripple through the entire system, design patterns um, are a way to build systems that are more robust and that have these stop gaps where a change that needs to be made in one area doesn't require a ripple effect through everything else. I often liken that to the impact that fire doors have in a large building,
That's right.
right?
That's a good
If
example.
you have a fire breakout in one room and you have these fire doors that stop the fire from spreading to the other rooms and then the whole building, then you can isolate and contain that change or that fire, the impact that it has. And design patterns are like these fire doors to the entire system. You need to make a change here, fine, deal with it, but then past these doors or these abstractions, then the rest of the system doesn't need to change. It doesn't even know that something happened there. And
Yeah.
so the limitation to or the inability of having these cascades that ripple through the entire system, that I think is a nice analogy there.
Yeah. There's another piece of this. I'm really glad you're talking about this and great question, Abisi, and good follow-up. There's another one, which is how do you keep people in sync at the same time? And this is why visibility across the organization is so important. This is where you get alignment from things. And this is where the one of the thing about a pattern that's so cool is if we talk about how these things relate to each other, then what you have to do is the implementation of one to the other is not important, but that relationship must
Mhm.
be at least constant if it can be, or at least clear if at a minimum. And that's another way of even if you're coupled, it's proper coupling because you can see what's going on. Yeah, Susan, it looked like you had something to say.
Yeah, I was just going to say that this is yet another argument for having a culture of learning and agency as opposed to a culture of fear, because then you have more people who are alert to something strange happened and more willing to mention it
Yeah,
instead of saying, "Oh, I knew that 20 years ago
yeah,
when a
that's a good
disaster
point.
happened."
See, once you recognize that the system has a certain amount of impact on us that we can't change. You can't change that nature of the systems. It can allow for, we talked about this yesterday in the work session of Amplia University. We have there's, besides this session, we have 3 content type sessions where we co-create something. But Monday afternoons is kind of a thought where they help me figure things out. And one of the things that I started talking about was reframing. And what we need to do is reframe complex systems from, oh, and not that people say this, but people inside their head say this, is I don't know how to do this, I'm a failure. Because if you're a knowledge worker and you don't know how to do something, somehow that makes you think you're less valuable. This is buried deep for a lot of us, but it's still there. So you don't want to do that. So you resist that and say, yeah, let's figure it out and do it. But when you actually recognize that some things are beyond your understanding and that that's okay because that's the way it is, then you can reframe complexity by, instead of saying, oh, complexity stops me from being able to do things, woe is me, I'm upset, I don't like it. You could reframe it that my job is to learn how to deal with new things in complex situations. And I, like you said, Susan, the agency and the ability to learn as I move forward. And yes, I won't get to the point where I can see everything that's happening, but I can get to the point where I can be more effective. And a learning organization is about continuous learning. And this has been lost in the Agile space. This is, by the way, the main lesson of Lean. I've read a lot of books on Lean, and there's a lot of stuff there. There's value streams, there's just in time, there's automation, there's the undone chord and all sorts of stuff. There's Deming and all that. But Lean is mostly about continuous learning. Toyota Kata is a brilliant book, by the way, if you haven't read it. And it's their learning process. Okay. Well, this today went a little different because I didn't think I was going to spend the whole hour on this, but I thought this was good and it makes me think. So I'm going to ask for feedback of anybody who's here and anybody who's watching this for what I can do. I can do one of 2 things next session. I still haven't had a full Q&A session, which is what I was wanting to have here. And maybe we do both, and maybe we do the Q&A first for half an hour, and then I get a half an hour for this other topic that we co-create with, is how do we take what we said here a step further? In other words, what are the different mechanisms for decoupling? I'm a little worried about going too deep because at some point you have to know what to do, and we haven't covered that here, and I'm not going to in the community practice. That's reserved for the other sessions. Let me think about it, but please send me an email if you've got a topic. If maybe just say Q&A, I got questions, that'd be great. I actually have some interesting ideas about reframing frameworks, and therefore may talk about the challenges with frameworks as well as yours. So anyway, any closing comments or questions? Good. Okay. Well, I'll get this up. I thought this was a good conversation. And Thomas, thanks so much. And everybody else too, the comments made. Very good. Take care.
Thank you.